Hello, let's go through exam VWO 2021, the first period. The idea is I provided videos of 2022, all three exams, and I will also do all three exams of 2021, which is a total of 6 exams. And my guess is that with these 6 you have a pretty good picture of what kind of questions you can expect and what kind of skill sets you need. Alright, first. And by the way, you can check first how many questions there are. Actually 14. So you have 3 hours, which is 180 minutes. So you can say, okay, let's try to spend 10 minutes per question. If I exceed 10 minutes or I don't have the answer yet, I leave the question open and go to the next, because there's definitely some differences in difficulty. And at the end, well, you're either completely stuck or it turns out you have some time to go back to the questions that you needed more time for. Alright, so we have a function f given here, and they say this point is on the graph, which is pretty obvious if you substitute this. There's a raakline, which is a tangential, and in the oorsprong means in the origin. And that one is perpendicular to a line M, which goes through this point T. And then we define a certain region phi, which is enclosed, bounded by line M and the graph F. And what they're asking is calculate exactly the area of phi. So definitely something you need to know is exactly what that means, how to calculate such an area, and it's just the integral of the difference of these functions from, say, the first point A, which is already given, which is 1/2. So we need to integrate from 1/2 till this intersection point. We call B here, which we need to calculate after we found line M here. So let's figure out what line M is. So I've pre-written the solutions already to save some time. Well, it is perpendicular to L and it has to go through point T here. So use what we know about the angle between, what we know, what makes a line perpendicular to another. Well, if the slopes of the two lines multiply to -1, so the product is -1, then they're perpendicular. And line L, we can actually calculate the slope because we know it's a tangential of the function f in the origin. So the slope of it will be the derivative of f in 0. This should be standard knowledge to find the derivative of this function and substitute x is 0. Then you get 1. So the slope of L is 1. This means that the slope of M is -1. Then you just set up a expression for the line with the so-called y-intercept b as an unknown and demand that this point is on the line, and with some algebra you find that b is 3/4. Okay, we have line M now, and now we intersect it with f, so we get this expression here, this equation, bring everything to one side and combine the like terms. Then you find this equation. There's a 4x squared here, and you can either just use the equation with the discriminant, or you can just maybe spend some time and just try to factorize it. So either x or 4x to make it 4x squared, which turned out not to work out, but you can try then 2x and 2x, and just try the different factors of 3 to find something that works. And this is what you get. X is 1/2 and 3/2. X is 1/2 is actually t here, so we wanted to calculate b, so we take the other one, 3/2. So now we know our bounds of the integral, and now we need to find the primitive of this. That should also be standard knowledge. Well, actually we should get a primitive of the difference of the function, so we first write f minus m, which is x minus x squared minus the expression for m, and then for this one we take the primitive, which is pretty straightforward, given here, and that gives us then the area by taking the primitive between these bounds. That is, yeah, you just need to be careful with the algebra here. It's very easy to make mistakes with minus signs, etc., and that is really a pity if that happens. And you just you get all these fractions to power. Just do it slowly and steady, and double checking every equal sign. Yes, it takes more time, but if you make a mistake, you can actually lose double the time if you don't do it. So in this case, you can just put it all under the denominator of 24, all the different expressions, and you get 1/6. So one of the skills you need to know about the tensions, what makes lines perpendicular, the standard primitives, area enclosed by two functions, and how to intersect functions. Alright, so already spent 8 minutes on that. So you can see it is actually definitely not an easy exam, the amount of work that has to be done. It's definitely a grind. Question 2. Oh, okay, they say, where are we? We have these two functions. They have 5 gemeenschappelijke, means common points. 3 of these are on the x-axis. The other 2, P and Q, are not on the x-axis. And calculate the x-coordinates of P and Q. Okay, that's not too shabby. Just calculate where they intersect and take the points that are not on the x-axis. These are P and Q. Alright, so this is, let me see, we set the functions equal. Yeah, there are always multiple ways to do it. Actually, you can just set the arguments to be equal. and then with also some modulus some numbers of pi. So I did it here a little bit different. I just used the equation of the double angle, which is given in the exam. And if I do that, I can factorize the sine of x, and I get term 1 minus 2 cosine x has to be 0. Now that we have to look at both. So first sine x is 0, that happens when x is n times pi, if n an integer. And within the domain given here, that's 0 pi or 2 pi, which are the points that they already kind of indicated as being on the x-axis. Then this kind of equation you need to be able to solve. Also, if there's some factor in front of x, or some x plus something. Well, when is the cosine x equal to 1/2? It's either at 1 over 3 pi modulus 2n pi, or 5 over 3 pi modulus 2n pi. Another way, because the cosine x is actually symmetric in the y-axis, you can also write the second one as minus 1 over 3 pi, which gives the same results if you put it all back in this domain. And here we can just have, in both cases, n equal to 0, otherwise you will be out this domain. You can make a drawing, no matter how ugly it is, just as a sanity check, right? So it makes sense. So it's just over 1/2 pi, and then and the symmetry of the cosine will also tell you it will occur here. So 5 over 3 pi, which is what they were asking. Now we translate g by 1. Then we get the function h. And we have a area phi enclosed by f and h, which is grayed out here. They cross each other in 2 points. So they tell you that already. And the x coordinates, they also provide this to you already. They are given here, rounded. Calculate v, the area of v, with primitives in 1 decimal. Okay, so this is basic skills. You need to know how to calculate these. This f minus g from the x and y given there, and substitute the functions. So it's something with the sine of x and the sine of 2x. Well, just do the primitives of these and be aware of the chain rule. The primitive of the sine is the cosine, and so 2 sine x is just simply minus cosine x. And then did I say this correct? Just double check the derivative again. A derivative of a cosine is a minus sign. The cosine goes down initially. That is the way I remember that. So take the derivative of this, then you get minus sine x times minus 2 is 2 sine x. And for this, you have a factor 1/2. That's coming from the derivative of 2x. If I use a chain rule to calculate the derivatives, I get minus the sine of 2x times 2. So this 1/2 is compensating for that. and you get minus 2 sine 2x back. And then this one is, of course, is minus x. And that's, you just have to put into the calculator. And the answer should be 2.6. Now they say they give a function k 1/2 tangent of x, and raken means they have a similar tangent. I guess touch is not the right word in English, although let's just call it that. They touch in these 2 points here, and the x coordinate of that point is 1/3 pi. So yeah, this is of course 1/2 pi. There's a tangent there as an asymptote. And basically you have to prove that they touch in this point. So that's 2 things you have to do. First, the function have to have the same derivative, the same slope, and they also indeed need to intersect. So to just work it out, just substitute the values. You have to know these the sine and cosines of these standard angles, like 1/3 pi, 1/2 pi, 1/6 pi, etc. There's, for the rest, not really difficulty here. Can just be very precise and double check everything. The derivative of function f is just is pretty simple. For the tangent, I guess you also better just learn that it's 1/cosine squared x, but if not, you just calculate it from sine x divided by cosine x and use the rule for the quotient of functions and how to calculate the derivative of this. That's definitely something you need to know. So f this function derivative is g f prime minus g prime f divided by g squared. If you do that, you'll find the same. Anyway, you can see here you've proven both 1 and 2, so you've answered the question. Okay, we're picking up on the schedule. This is a question about earthquakes. So again, this is a word problem. And unfortunately, you have to just understand the Dutch of it with a lot of non-mass related terms. But basically in an earthquake you have 2 kinds of waves. Primary waves and secondary waves, and the primary waves are faster. So if an earthquake happens, these are the ones that you measure first. They also give the speeds of these, and they say that a certain station measures a difference of 17 seconds between the primary wave and the secondary wave. Of course, the primary wave arriving earlier. And with that information, you can calculate the distance d. So yeah, just translate this all in some math equations. You can define the speeds of the primary and secondary, and just see how that relates to the distance for each. So obviously these are, both will have the distance d in it. And from this you can derive that the time of arrival for the primary wave is the distance over the speed of p of the primary, and for the secondary it's just a distance divided by the speed of the secondary wave. And what you measure is the difference, and Ts is larger because the Vs is slower, so it takes a longer time for the secondary wave to arrive, as I mentioned. So get Ts minus Tp is this expression, and it has to be 17, and we also can substitute what we know. So you get this equation, and well, just substitute it and use your calculator. 17 divided by this, and you should find 142.8 kilometer. They generally use different measurement stations, and let's say you have two measurement stations, S and T, and they give the coordinates in km of both, and they find that the earthquake happened at a certain distance, to 40 kilometers from S and 80 kilometers from T. So if you put this in a coordinate system, and just for convenience put S in the origin, then I'm really bad in drawing circles, so I probably won't definitely won't do well. I cannot even. You get a circle around S with a radius of 240, and a circle of some radius 80 around T, and the epicenter of the earthquake has to be in the points where these two circles intersect. And then the question is, calculate the two possible points of intersection. So yeah, obviously there are two possibilities if you cross a circle. So say there's there's some lag in the pad, but you get a circle here and say a larger circle around here, and there are two intersecting points, and what you do is just set up the equation for both circles and solve these. So this is the equation of the circle around S and this around T, and with this what you have to do is subtract them, because with a circle the coefficients in front of x squared and y squared are the same, or both 1, and they just nicely drop. Again, just be really slow and careful here, because if you make a mistake, you just spend more time. So subtracting these, you get, let's just do the first term, you get x squared here, then minus an x squared, so they drop, and then this term gives minus 2 times 192 times x, but with an additional minus sign here, so you get 2 times 192 times x, etc., etc. You get also 2 constant terms here, and on the right hand side too, if you subtract them. So you need to bring them all to one side, so you get like 4 constant terms here that combine to this number, and this doesn't look really pretty, but just use your calculator and just try to divide this by what's in front of y. You should play around a little bit with that, but then you get this relation, which means you can express y in x, and then you can substitute it back in the equations, and I guess the simplest is to put it back in the first equation, because the simple form. So you get x squared, and then the y substituted here. You get a quadratic equation, and here I would just plug it in to your graphic calculator. Just define a function y1, and cross it with a line, or just cross it with 0, and you get these two numbers. And now we just substitute it back into our equation for y. Don't substitute back in here, that becomes more complicated. We already know that the relation between y and x. And then they're asking it in whole numbers, so you get these two coordinates. Okay, then they say that the earthquakes have a magnitude. And they studied some relation between the magnitude and the number of earthquakes in that region. And fortunately, the more heavy earthquakes happen less frequently. And they also came, or researchers from here also developed a model which is of this form. M will tell you the magnitude, and N is the number of earthquakes with magnitude M or bigger. Or bigger. So again, you have to understand the Dutch here. A and B are constants, and from this table you're supposed to be able to make an estimation of the constant A and B, possible values. And then you can you could get this information by looking at earthquakes of scale 6 or bigger, which is 285.5, or 7.5 and bigger, which is 4.5. So 7.5 and bigger, so 3.1 plus 1.1 plus 0.3 is 4.5. Then they say you can use these to find values of A and B. Well, and all these numbers should add up to 85.5, right? That's 6 or larger. So that's then what we do. We take 6 for the magnitude, and then 285.5 for n, and 7.5 for the magnitude, and 4.5 for n. And then we get two equations with two unknowns. With these, you just take the logarithm on both sides to isolate the exponent here. So you get these two equations. And the most obvious thing to do is subtract them to eliminate A and to find B. So you get the difference of these logarithms, which you also can simplify a little bit, by the way. I didn't do that here. I just plug this in to find B, 1.201. Oh, by the way, they're not asking to give the expressions for A or B with certain accuracy. They are actually asking to use the A and B that you find to apply it to earthquakes of scale 6.5 and higher. So I just keep it to like 4 significant digits or 3 decimals here. Okay, so that's B. What's A? Well, just use any of these equations to bring B here to the right and plug in our number for B. Again, use your graphic calculator, then you get 9.66. So if then we substitute, use this for m equals to 6.5. Actually, I think this is a bit of a mistake. I should say if m is 6.5, then the n is would be the number of earthquakes with magnitude 6.5 or higher. So substitute in our equation for n. Can a lot of calculator work. You get 71.36. And now they're actually asking how does it afwijken, means how it deviates from what's given in the table. Well, what's given in the table for 6.5, I need to add all these numbers, 65, 3.1, 1.1, 0.3. Do that to get 75.5. If you want to be smart, you can, since we already know actually for 6 or higher, it's 285.5. So all this added should be just the difference between 285.5 and 210, which is the same. Okay, so what's the difference between the two? Well, it's 4.14. And as a whole number, that's 4 years less than in the table. Not 4 years, sorry. That's 4, not 4 years. 4 quakes, earthquakes. Sorry. I'm sure they wouldn't have counted as a wrong answer. Okay, question 8. We are given a square with corner vertices given here, and we have a point P and a point Q, and 3 vectors CP. So this means a vector pointing to P from C, a vector pointing to A from C, and a vector pointing to Q from C. And then we have to prove that for every value of P, the angle between CP and CA is equal to the angle between CQ and CA. So basically this here, CA is a bisector of the angle at this angle at C. Now there's probably some geometric way to get the answer, but let's just not take the risk that this is difficult. I would just do the brute force approach. And actually there would be 2 approaches. You can write down an expression for each of these, and you can find the angles, the difference in the angles from difference in the slope. But in this case, it's probably most straightforward to use some vector mass that is also part of the material. And in particular that, since they're talking about angles, that the angle between 2 vectors can be gotten from the inner product. This is some knowledge that is required. So let's do that. Let's find out what is the vector from C to P. Now remember, if I have 2 vectors, say A and B, then the vector connecting B and A is actually B minus A. So just plug in what we know. We can find this expression for P minus C, this expression for CA, which is A minus C, and then we calculate the inner product divided by the magnitudes of each vector. So here inner product is just the x component plus the y components multiplied. So you get P times 1 plus minus 1 times minus 1 is P plus 1. The magnitude of this vector P minus 1 is square root of P squared plus 1, and the magnitude of this vector, of course, is the square root of 2. Um, and now also calculate the other angle between CQ and CA. We already have CA here, so that we just need to find what QC is. Well, Q here, x coordinate is 1 over P, and etc. You just easily find this factor for CQ. Then again, we do the same trick to find the angle. I shouldn't say angle, by the way. I should say the cosine of the angle. This is giving you the cosine of the angle. Okay, and the same here. So from this, you find that the cosines of the angles is the same, but it also means the angles itself are the same. Then there's a point M, which is in the middle of segment PB. And you can then also define a vector from Q pointed to M. And for certain P, they chose P such that QM is perpendicular to PB. And find for which value of P that happens. And 2 decimalen means 2 decimals. Okay, well, let's first construct M. The middle of a vector between 2 points is just 1/2 and the sum of the 2 vectors. And filling that in, we find 1/2 times P plus 1 and 1. And now what we have to do is find the vector BP, which is the vector pointing in the B direction, and the vector QM, and demand that they are perpendicular. And a perpendicular means that the inner product is 0 from the equation in the previous question. You also can set up a line and find the slopes of each, and then this demand that the product of the slopes is equal to -1. Should give the same results. Okay, so BP is factor 1, 1 minus P0 at the coordinates of B, so 1, 1. This is P0, and for QM we have 1 over P0 for the coordinates of Q, and we found M here already. So you get this. There's a 1 over P and a linear term at P as well, so a little messy. Now calculate the, well, this is not exactly equal sign. What we want is the cross product, and that's actually what's given here. So BP, sorry, not cross product, inner product, QM is equal to this, or again you just multiply the x components plus the product of the y components, and just get 6 terms here. 1 times 1 over p, 1 times minus 1 half p, 1 times minus 1 half, etc. Then it turns out that the terms linear and p drop, cancel each other, and this is the final expression you get, and we set it 0 to be perpendicular. So this has a 1 over p, which is a little unusual. Since I want to asking the answer into 2 decimals, it indicates it has to be done analytically, and you can just already put it in your calculator here, or you can that's something I can show in Wolfram Alpha, but you can do that in the graph calculator as well. So 1/2 times p squared minus 2 plus 1 over p is 0. Oops. You can define a function of x and intersect it with line y equals to 0. And we also know p has to be between 0 and 1, so you find that this is the solution. We actually erase this. You don't need to do this. We don't want to do it analytically anyway. What you get, you can just substitute like a u is 1 over p in this, and then you get some third degree equation, which is often not so straightforward to solve. Okay, now they have a question about a equation of motion describing this form here. And we have a vertical line, x is a. If a greater than 0, it intersects x-axis in point Q, and then this form in R and S. And the y-coordinate of S is greater than the y-coordinate of R. And then they state if a is increasing without limit, so the limit to infinity basically, then the ratio QR over QS, QR over QS will approach a certain limit, and we need to calculate it exactly. Well, this step by step, the strategy would be to calculate QS and QR as function of A. So where does it cross? Well, x has to be A. So looking at it, it means t squared has to be A. And when does that happen? Well, if t is plus or minus the square root of A. And we need to know the y's, because we want to find these line segments here. So y is A, as by substituting it, y is the square root of a squared, which is a, and then minus 2 times the square root of a. So these are the two solutions, and they already tell us that the y coordinate of s, I probably should call it y s actually. Anyway, this is the y coordinate of s is a plus 2 times the square root of a, and the y coordinate of r is a minus 2 times the square root of a. So now we know our QR, and the y coordinate of q is 0 both cases, so it is a minus 2 times the square root of a for QR, and QS is a plus 2 times the square root of a. So now we can just calculate the ratio and let a get larger and larger. Well, you can already see what happens. The linear term in a will dominate the square root, and you get something like 1 over 1. And like the slightly more formal way is in case of polynomials you of equal degree, you just divide by the highest degree in or the variable to the highest degree, both denominator and numerator. So divide both by a, you get 1 minus 2 times 1 over the square root of a, or 1 plus 2 times 1 divided by the square root of a. And if a goes to infinity, these two approach 0, so you get 1. And that should be that limit. Interesting. Next question, 11. We have a function fp given here, and this is the graph this is given for the case that p is equal to 1. And they say that f1 has a so-called oblique asymptote, which kind of makes sense if you look at it. And they just want to prove that this asymptote is actually below f1. f1 is above this asymptote. Okay. Well, in these, since the numerator has a higher degree than the denominator, you can do kind of a long division, which is actually pretty trivial here because there's only an x squared term, but I still demonstrate it here. But you can actually already immediately see that it's x plus 4p over x squared. And this will approach x if x goes to either negative or positive infinity. So that's the asymptote. Y equal to x is the asymptote. Now, is the function below or above it? So we just look at this. We say, if fp of x is greater than x, we can just substitute a function. Then it means 4p over x squared is greater or equal 0. And actually these all work in both directions. And since we know this is true, since x squared is always positive and p is positive as well, we find that this is true. Question 12. For every value of p, the graph fp has one top, one extreme. It's actually a minimum, as you can see for this example, and prove that there is a line, that all these tops, all these extremes are on a line. Okay, it's a little bit tricky. It means that, so for every p, if you would plot it for, say, p is 2, 3, 4, 5, the coordinates of the extremes are all on a line. Well, let's just first do the calculation. Let's, for certain p, calculate the derivative and set it equal to 0. And we call xm as the x-coordinate of the extreme. So we set the calculation of the derivative is pretty simple. This is just minus 2x to the power minus 3. And setting it to 0 will tell you that the extreme is at satisfying this relation. So if p equals to 1, it would be at x equal to 2. So then, okay, what is the y value? So we know the x value. What's the y value? We need to substitute this extreme in the function. So we get xm plus 4p over xm squared. And this is, and then we also know that p and xm are related in this way. Because this is actually the extreme, the x-coordinate of the extreme that belongs to the p given here. So substituting that in, you get an x cubed divided by x squared. That basically becomes linear, and you get 1.5 times xm. So they're all on a line. So let's take the example of p is equal to 1, then since xm cubed has to be 8p is 8, you get xm is equal to 2, and the ym is equal to 3. So that's this example here. Okay. Next question. We have a function given by the absolute value of a logarithm of x. And the horizontal line y is q greater than 0. It crosses the y-axis in A, and then the graph in B and C. And xb is less than xc. And then they say there's a certain value of q for which bc is 3 times as large as AB. Okay. Well, find AB and BC. That means we have to find these intersections, and we set fx is equal to q. That means the absolute value of log x has to be q. Now, with things you have to be careful. You first need to make, you can only do this by making an assumption on the log x, the sign of log x. So let's first assume that x is such that the logarithm is greater or equal to 0, and then the equality becomes log x is q, which means x is e to the power q. But again, that's only when x greater or equal to 1, which depends on your q. For a small q, actually this would not be true necessarily. And now assume that x is such that the logarithm of x is less than 0, which happens for x less than 1. Then we find minus the logarithm of x equals to q. And remember, the absolute value of a is either a or minus a. So if a larger or equal to 0, or a is negative, then it's minus a. So it's important then later to check if you made the right assumption. So now we know BC and AB. BC is the distance here, so it is e to the power q minus e to the power minus q from B, and AB is e to the power minus q minus 0. And so I assume that's so this is actually point C, this is point B. And it's also given xc is greater than xb. And they say it has to be 3, or actually asking when it is 3. That means that this expression is 3. So e to the power 2q minus 1 is 3. So e to the power 2q has to be equal to 4. Or 2q is the log of 4. So we take a logarithm on both sides. Then you get q is 1/2 times log 4. And now we just need to still check if our assumptions were correct. So if q is half log 4, then you can actually calculate your x back, and you'll find that it's indeed it's 1.99, is greater or equal to 1. And for the q of b, it is e to the power minus q. Again, substitute q is 1/2 log 4, and it's 0.5, which is less than 1, so the assumptions were correct. So this is the final answer. Actually, the last question, guys. We have a function 6 times the square root of x. Point P is on the graph to the right of the y-axis. Okay. And it's chosen so that there is some P prime with the following properties, eigenschappen. It's on the negative x-axis, so y is 0. And this line segment has the same length as OP, and the angle spanned here at the origin is 120 degrees. Well, again, step by step, construct the line OP. And here, there's always two ways to this. I just use the slope-intercept form of a line. And well, what is the slope here of this line? It's using the straight angle. It's 180 minus 120. And the slope is the equivalent to the tangent of the angle. So let's calculate the tangent of 60. You either memorize these or just memorize the sines and the cosines. You get the square root of 3. And since it goes to the origin, the b-intercept actually becomes 0, so it's just y equals the square root of 3 times x. Now we intersect it with the function, so you get two equations, two unknowns. We just eliminate y, we put them equal, and we have a square root of x here in x, so we just square both sides, and you get two solutions, x equal to 0 or x equals to 12. If x equals to 12, then y has to be equal to 12 square root of 3. You just substitute it in one of the functions. So this is our point P. And then what's the length of OP? Well, we use Pythagoras. It's 12 squared plus 12 squared times 3. You can actually pull out the 12 here. Well, you can just put it in your calculator if you will. Why not? It's the last question. But you can pull out, you can factorize 12 squared and then take the square root, so you get 12. And 1 plus 3 is 4, so you get the square root of 4 times 12 is 24. So that's the answer, and that completes this examination.